Hi everyone, we're Ankit, Ginny, and Ert, and we're going to be talking about the Aurora generator test. So, what exactly is this test and what happened? Now, the Idaho National Laboratory ran the Aurora generator test to show how a cyber attack to destroy physical components of an electric grid. This attack also extends to other hardware, such as other things that spin, that have motors in them. The experiment used a program to rapidly open and close a diesel generator's circuit breakers out of phase from the rest of the grid, making it explode. This vulnerability is called the Aurora vulnerability, and the code used to hack the generator was just 30 lines, which is smaller than the size of a captive, which is pretty crazy to think about. Now, why was this done? Previously, it had been believed that within the electrical industry, that any cyber attack could be dealt with similarly to any other outage, and the grid could come back up relatively quickly. They were very confident in their ability to prevent cyber attacks because they weren't really thinking from a more security mindset. And so Mike Assant, who was previously chief security officer at American Electric Power and then at the Indiana National Laboratory, believed that it may be possible to cause physical damage to generators, making a quick restart impossible. And he was pretty effective at doing this. Now, as for the actual details of the experiment, for the setup, the researchers installed a 2.25 watt generator and connected it to the substation in a power plant. They also needed access to a programmable digital relay or another device that controls the breaker, which most generators and power plants these days have because the world is getting more digital and remote access is pretty important for these things. Now, during the attack, the researchers opened and closed the breakers out of sync to maximize stress. What this means is the turbine that spins inside the generator was made to stop and restart when it was out of sync with the rest of the things that it was connected to, making it jump up and down erratically and smoke and all that kind of stuff. Each time the breaker was closed, the torque from the synchronization caused parts of the generator to rip apart and fly away as far as 80 feet. That's really, really far away, and we can see that in the video that we'll show you coming up. The unit was completely destroyed in 3 minutes, but it's speculated that if the attacker was more malicious and actually wasn't just experimenting and wanted to do actual harm, it would take less time. About 1.5 minutes is the approximation.
Yeah, so the specifics of the attack, as previously mentioned, it's caused by an out-of-sync closing of the protective relay, which the protective relay is effectively a safeguard sort of component in most generators that ensures that they connect to the local network or disconnect when they're in or out of sync, respectively. And so this attack compromises that protective relay and forces the generator to deliberately speed up or slow down to go out of sync, then reconnect to the grid, cause the damage, disconnect, and then rinse and repeat as many times as necessary to destroy the generator. And so traditional generators normally sort of regulate themselves, even without the protective relay, to ensure that, like, if they're detecting anything wrong, they will, like, stop everything about every 15 cycles, which this attack just makes sure that it's happening in time less than it takes for the generator to go through 15 cycles, so that the generator can't detect that something's wrong with itself. And this makes this kind of attack particularly effective against machines that haven't been built with security in mind, because just more frequent checking or another component watching for this happening would solve this issue. And so here is a video demonstrating the attack, which something to keep in mind is this is a piece of heavy machinery that you're going to see jumping around. So the potential impacts of this attack are that the failure of even a single generator in a power grid can cause widespread outages and even a cascading failure throughout the entire grid, as occurred in the Northeast blackout of 2003. And even if there isn't a cascading failure or outage, so the grid manages to stay up, changing a generator to take the place of the destroyed generator could take about a year, which means any further attacks would cause irreparable damage to that grid, and the grid would collapse. So many power grids are not set up with cybersecurity in mind, as previously mentioned, so exploitation of this vulnerability could be far easier than we would like to think.
Okay, so now that we've talked a little bit about what the Aurora generator test was and what the specific vulnerability in that test was, now we're going to talk just a little bit about how we can do things to prevent that attack from being used against us in the future. So this attack can be mitigated by preventing the out-of-phase opening and closing of the breakers. As you remember, the breakers are doing the majority of the damage here, so fixing that problem would be very good in kind of preventing this attack from happening. So some suggested methods for doing that are adding increased functionality in protective relays to ensure synchronism, as we kind of talked about earlier, and adding a time delay for closing the breakers. One example is to add a synchronism check function to all protective relays that potentially connect two systems together. To implement this, the function must prevent the relay from closing unless the voltage and frequency are within the preset range. And then, in theory, we could be able to stop this attack. So these would be relatively low cost and feasible to mitigate and to implement in mitigating this attack, but the Aurora vulnerability hasn't received too much attention in recent times, so as far as we know, this hasn't been implemented on a large scale. So just to go over some further implications of what the generator test and the vulnerability it showed kind of mean for us going forwards. So first of all, other heavy machinery that rotates could be vulnerable to a second attack, a similar attack. If you look at our image to the right, you can see a whole bunch of different areas of society that kind of rely on these rotating machines. That are connected to utility power. This is from Homeland Security in kind of their unclassified documents on the Aurora generator test. So as you can see, they've got water, railroads, electric, shipping, oil and gas, refinery, and these are all kind of sectors that America at least relies really heavily on, and so do many other countries. So attacking one of those, especially if it was a big attack that took out a lot of things, would be very bad. As we all know, the ransomware attack on the gas and oil pipelines in very recent news caused a lot of damage. I would imagine it would be very similar amounts of damage if something like this happened. And given the prevalence of that ransomware, it's possible that a new form of cyber ransom threatening the physical infrastructure rather than the computer data could one day emerge if we don't deal with this vulnerability on a larger scale. So just to end this off, the Aurora vulnerability hasn't received too much attention recently, but there are a couple of similar attacks that have happened. For instance, Russian hackers used a very similar attack against the Ukrainian power grid to cause a blackout in 2016. Russian hackers, as we all know, are very infamous for getting their noses into all sorts of things they should not be messing with. NSA's Stuxnet malware also caused Iranian nuclear centrifuges to destroy themselves in 2009 as kind of a different example of a different sector you could potentially target with this kind of attack. So Aurora-like attacks may not be that commonplace or that in the news, but they could certainly cause blackouts and physical damage to equipment, and therefore it's worth knowing about it and taking some steps in order to prevent this from happening on a larger scale. And here, of course, are all of the citations and sites we looked at for this presentation. Thank you all for watching, and hopefully you've learned something about cybersecurity.